Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. In this episode, our lesson is still about the applications of the different exponent rules. And this is the part 2 of this topic. If you did not yet watch the first part of this topic, find episode 82 and you may watch it after this video. As I mentioned in episode 82, there are 3 types of questions about this topic. And in this episode, I will be teaching you how to solve the second and the third type of questions. Okay, let's continue with the second type of question. And this is about expressing equations in terms of variables. In here, we will represent equations in terms of variables. And for you to understand this type of question, let's give an example. When 2 raised to the power of x is equal to this variable a, how is 2 raised to the power of x plus 2 raised to the power of x plus 1 expressed using a? Okay, take note. 2 raised to the power of x is equal to a. So this is a. Okay, what about 2 raised to the power of x plus 1? 2 raised to the power of x plus 1 can be written as 2 raised to the power of x times 2. Okay, rule of exponents. Same basis. This is multiplication. So copy the base 2. Then add the exponents. So 2 raised to the power of x plus 1. So these are just the same or equal. Okay, 2 raised to the power of x. This is a or variable a. So a plus a, okay, times 2. This is addition, this is multiplication, so we need to multiply first. A times 2 is 2a. So a plus 2a, so the answer is 3a. Okay, let's move on to this simple activity. Okay, if 2 raised to the power of 4 is equal to this variable a, how can 4 raised to the power of 10 be expressed using a? Okay, 2 raised to the power of 4 is equal to this variable a. But this 4 raised to the power of 10, the base is not 2. Okay, remember, 4 can be written as 2 squared. 2 squared is equal to 4. So put 2 squared inside the parentheses and raise it to the power of 10. So this is just equal to this one. Okay, apply the power of a power rule of exponent. So we will just copy the base 2, then multiply the exponents. 10 times 2 is 20. So this is equal to 2 raised to the power of 20. Okay, take note, 2 raised to the power of 20 can be written in many ways. Okay, this can be written as 2 raised to the power of 4 inside the parentheses and raise it to the power of 5. So if you will multiply the exponents, then this is just equal to 2 raised to the power of 20. Okay, another. 2 raised to the power of 5 inside the parentheses and raise it to the power of 4. Okay, can also be 2 raised to the power of 10 inside the parentheses and raise it to the power of 2. Okay, or 2 raised to the power of 2 inside the parentheses and raise it to the power of 10. These are all equal to 2 raised to the power of 20. But since we need to express this using a, and a is 2 raised to the power of 4, okay, we have to get this one. So this is 2 raised to the power of 4 raised to the power of 5. 2 raised to the power of 4 is a. So that means a raised to the power of 5. So this is our answer. Okay, now, let's go to the third type of question. And this is finding the number of digits. In here, we will calculate the number of digits in a power. Let's recall briefly. When we say digits, okay, for example, this number 99. This is a two-digit number. Number 100, okay, this is a three-digit number. What about this number? 2,300. 2,300 is a four-digit number. Okay, and so on and so forth. Okay, and then, if you're going to take a look at 2,300, we can actually write this one as 23 times 100 because 23 times 100 is equal to 2,300. Okay, in this type of question or problems, we have to recall these concepts. Okay, we know that 2 times 5 is equal to 10. Okay, we already studied this one. So if we have 2 raised to the power of 2 times 5 raised to the power of 2, then this is equal to 10 raised to the power of 2. 2 raised to the power of 3 times 5 raised to the power of 3, this is equal to 10 raised to the power of 3. 2 raised to the power of 4 times 5 raised to the power of 4, this is equal to 10 raised to the power of 4. Okay, and so on and so forth. So we already know this one. We will use this concept to answer problems like this type of question. Okay, let's give an example. When 2 raised to the power of 10 times 5 raised to the power of 8 is an n-digit natural number, what is the value of n? N here means the number of digit. Okay, our given is 2 raised to the power of 10 times 5 raised to the power of 8. Okay, we get here 5 raised to the power of 8. 2 raised to the power of 10, take note, we have to make this one like this. So we can know how many digits are there. Okay, 2 raised to the power of 10 is just the same if we will write as, okay, 2 raised to the power of 8, okay, times 2 raised to the power of 2. 2 raised to the power of 2 times 2 raised to the power of 8. So this is just the same as 2 raised to the power of 10. So this is times 5 raised to the power of 8. Okay, now, look at this one. 2 raised to the power of 8 times 5 raised to the power of 8. This is equal to 10 raised to the power of 8. 10 raised to the power of 8 means 1 and then the number of zeros are 8. So this is like 1, 2, 3, 4, 5, 6, 7, 8. So if we will multiply this one by 2 raised to the power of 2 or 2 squared, this is 4. So 4 times 10 raised to the power of 8 means, okay, 4 and then you just need to add the 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. So n-digit natural number, n is 8 plus 1. So that means this is a 9-digit natural number. Okay, let's move on to this simple activity. When 2 raised to the power of 9 times 5 raised to the power of 11 is an n-digit natural number, what is the value of n? Meaning, how many digits is this natural number? Okay, we have here 2 raised to the power of 9 times 5 raised to the power of 11. Okay, copy 2 raised to the power of 9. 5 raised to the power of 11. This is just the same if we will write as 5 raised to the power of 9. Okay, and we still have 5 raised to the power of 2. So this is just equal to 5 raised to the power of 11. Okay, so this is 2 raised to the power of 9 times this one. Okay, look at this one. For 2 raised to the power of 9 times 5 raised to the power of 9, this is equal to 10 raised to the power of 9. This means, okay, 1 and then how many zeros? 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we will multiply 10 raised to the power of 9 times 5 squared, okay, 5 squared is 25. So this is times 25, meaning our answer is 25 and we just need to write the 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the value of n here is 9 plus 2, so 11. So this is an 11-digit natural number. Okay, now let's answer the following problems. Okay, the first one is when 2 raised to the power of x is equal to variable a. Okay, how is 2 raised to the power of x plus 1 plus 2 raised to the power of x plus 2? Okay, 2 raised to the power of x plus 1 can be written as 2 raised to the power of x, okay, times 2. Okay, what about 2 raised to the power of x plus 2? So this can be written as 2 raised to the power of x, okay, times 2 squared. Okay, our operation is addition. 2 raised to the power of x is a. So this is a. Okay, this is also a. So a times 2 plus a times 2 squared is 4. A times 2, this is 2a. A times 4 is 4a. So 2a plus 4a. So our answer is 6a. Okay, let's move on to the second problem. Given that 4 raised to the power of 9 times 5 raised to the power of 21 is an n-digit natural number and the sum of the digits is a, what is the value of a plus n? So in this problem, n here is the number of digits and a is the sum of the digits. So the first thing we need to do is we have to find out how many digits are there in this number. Okay, we have here 4 raised to the power of 9 times 5 raised to the power of 21. Okay, this 4 can be written as 2 squared. 2 squared is equal to 4. Okay, 2 squared, put inside the parentheses and raise it to the power of 9. Okay, if we are going to simplify, we will use the power of a power rule of exponents. So this is equal to 2 and then 9 times 2 is 18. So we have 2 raised to the power of 18, okay, times, this is 5 raised to the power of 21. Okay, 5 raised to the power of 21 can be written as 5 raised to the power of 18, okay, times, we still have 5, we have remaining 5 raised to the power of 3. So this is just equal to 5 raised to the power of 21. Okay, let's copy 2 raised to the power of 18 times 5 raised to the power of 18 times 5 raised to the power of 3. 2 raised to the power of 18 times 5 raised to the power of 18. This is equal to 10 raised to the power of 18. Take note, 18 here is the number of zeros. So 1 and then 18 zeros. So 10 raised to the power of 18 times 5 raised to the power of 3 is 125. So if we will multiply these numbers, that means 125 and then 18 zeros. So 1, 2, 3, 4, 5. So this 18 zeros. So n-digit natural number, 18 plus 3. So it's 21. So n is 18 plus 3. So it's equal to 21. Okay, what about a? A is the sum of the digits. Since these are zeros, So you just need to add these numbers. 1 plus 2 plus 5, this is equal to 8. The question is, what is the value of a plus n? So 8 plus 21, so this is equal to 29.